Okay, video lesson 4.2, evaluation of sinusoidal functions. This is going to be a lot of algebra, but you are going to get to use your calculator on this, so go ahead and have that ready. It says for each of the following functions, use algebraic methods to A, find f of x for the given value of x, and B, find the general solutions and the first three positive values of x for the given value of x. And the next lesson, 4.3, actually uses this information in a real-life setting. So if you're wondering why we're doing that, you got to watch 4.3 video. Also says round to 3 decimal places. That's pretty standard. And that means not rounding in the middle and then rounding again and rounding again. It means your final answer should be accurate to 3 decimal places. And then there's a way we can check this by graphing, and I'll show you that as well. So, number 1, f of x equals 2 plus 3 cosine pi over 9 times x minus 6. Find f of 8. So, what this is asking us to do is to plug in 8 for x and evaluate. What would f of 8 be? So, pretty much what we're doing here is we're plugging it in. And you have to do this on the calculator. The reason is cosine of pi over 9 is not something that you know how to do, let alone if I plug it in 8 minus 6 would be 2, so really you're finding cosine of 2 pi over 9. That's not something you know how to do. So on your calculator, make sure you're in radians mode, by the way. This is going to be all in radians mode. And so let's type this in. We've got 2 plus 3 cosine. Now you need to ensure that everything you type in next is going to be in parentheses. So I'm going to go ahead and type in the pi over 9 this way. And its own set of parentheses, the 8 and its own set of parentheses. All in a larger set of parentheses, that cosine is being taken, that whole quantity. Now definitely you could have determined that 8 minus 6 is 2, like what I said, and then typed in 2 pi divided by 9. It would have been the same thing. So to 3 decimal places, my answer is 4.298. So I'm going to write a little approximation sign. So 4.298. Okay. Now doing part B is a little bit more difficult. I'm going to switch colors here. I'm going to let my pen go a little bit less thick. Okay. So this time I'm giving you the y value, and so I'm going to plug that in for f of x. Okay, so I'm going to type in 1.3 equals 2 plus 3 cosine pi over 9 and then x minus 6. And I need to solve algebraically for x. You can use a calculator, but you need to show all your steps algebraically. So the first step here would be to subtract 2. Okay, we haven't been solving very many equations yet this year, so this will kind of get you back used to that. So 1.3 minus 2 is negative 0.7, equaling to 3 cosine pi over 9 x minus 6. Okay, now I need to divide by 3. So I'm going to go ahead and just do that like this. Okay, we're good to go. Now I have a ratio equaling cosine of an angle. And remember that it's cosine of all of that. Okay, so how do you unpack this? Well, it means that my angle here, pi over 9, x minus 6 is going to be equal to arc cosine of negative 0.7 over 3. Okay, so let me repeat what I did here. I have a ratio equaling cosine of an angle. It's the angle, though, that I don't know. So I'm going to let this expression, pi over 9 x minus 6, representing my angle, equal arc cosine or inverse cosine of negative 0.7 over 3. This is why we did so much practice before, so that you could understand what's going on here. Now arc cosine negative 0.7 over 3, they're asking us basically for a principal value here, but I see the word general solution, and that's what makes this a little bit more difficult. So at least though the principal value I can do in my calculator, because on my calculator Always gives me principal values correctly, except for arc cotangent of negatives, and I'm not going to ask you to do that, so everything's fine with that. So I'm going to type in second cosine of negative 0.7 divided by 3. And notice that I didn't go ahead and write that as a decimal, because then I would just have to be rounding and rounding, and I don't want to do that. Okay, so this is my principal value. Now I'm actually going to use this here in a second. So keep in mind that this is really not 1.806. It's 1.8063, blah, 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 blah. Okay, so keep that in mind. I'll come back to that, though. All right, so let's just write down what we have. I'm going to move up here, actually. Pi over 9 x minus 6 is equaling to the principal value, which is 1.806, and I'm going to go ahead and write plus 2 pi n, where n is an integer, positive or negative. All right, that's one of my general solutions. My other general solution is going to be pi over 9 x minus 6 equals. Okay, so now let's think about what the other general solution would be. We're talking about arc cosine here. All right, and before we find this one, let's talk about restricted range for a minute. Arc cosines, restricted range, puts you in quadrant 1 if your ratio is positive, which it's not, but in this case, quadrant 2 if your ratio is negative. Okay, and so it may be hard to tell since their pi is not in there, but my ratio is negative, and 1.806 is less than pi and more than pi over 2, so this 1.806 is in the second quadrant. Now, what is the other quadrant I would need to go to where cosine is negative? Okay, all students take calculus, so I would want to also go to this one. Okay, so let's think about how we would come up with this. When we were dealing with values that we were way familiar with, it was much easier. Here, it's a little bit trickier to come up with this, but really not that bad if you think about it. Let me switch colors here. So I want to go to quadrant 3. All right, so from 0 to here was positive 1.806 radians. All right, if I wanted to go to quadrant 3, the easiest thing really would be to go the back way, and that's going to be negative 1.806. All right, we're going to talk more about this in class, so I don't want anyone freaking out while they're watching the video. Plus 2 pi n. Okay, now we just need to solve these two things for x. Well, the first thing that we're going to have to do is multiply by 9 over pi. And I'm going to go ahead and use the different color for this. So if I multiply by 9 over pi, and keep in mind I'm doing this to both sides. All right, I'm just going to write it once over here so it's not going to get too messy. So it's going to cancel that. I'm going to be left with x minus 6. And when I distribute, okay, I'm going to have to multiply that principal value by 9 over pi in my calculator. Okay, so let's go ahead and do that. So times 9 divided by pi. Okay, 5, and I used the answer here so I wouldn't have to round and then have to round again. 5.175, keeping in mind though that it's not really 175, it's 174.669941. Continuing on. Don't round, and when you write it, you're going to have to round, but keep in mind that you're losing accuracy if you actually, when you go back to type it in, if you use the rounded version. So 5.175. Okay, now I'm going to distribute to the other side, the other 2 pi. So the pi's then would cancel, and then 9 times 2 would be 18. So this is now plus 18n. And the only other step to do here would be to add 6. And if you add 6 to this number right here, you would get 11.175 plus 18n. Okay, so here is one of my general solutions. Okay, let's come over here and do the same thing. I'm going to multiply by 9 over pi, separate it out that way, like this. And so again, cancel. I would be left with x minus 6 equaling, when I distribute here, I know in this particular case anyway, I'm just going to get negative 5.175. And when I distribute here, I'm going to get again plus 18n. And now when I add 6, it's a little bit more difficult. Okay, so let's go ahead and go to our calculator and make sure that we're doing this correctly. Maybe not on this problem it's that bad, but it definitely could be. So I'm going to multiply this by negative 1, and then I'm going to add 6. Make sure that I get the correct answer. So 0.825. Maybe you could have done that in your head. On some of them, though, it gets much more difficult. Plus 18n. And here is my other general solution. These two solutions right here represent all of the values of x such that when you plug them in, you get 1.3. Okay, or the intersections on the graph as well, and I'll show you that in a minute. Okay, so that's the answer to part A. All of that work for the answer to part A. Now part B, though, really not that bad. It says first 3 positive values. Okay, so I have 2 positive values already, so I'm going to write those down. 0.825 and 11.175. That's nice because they were positive. If they hadn't been, I would have to add 18. This is just like general solutions from before. And so to find the third one, I'm going to add 18 to the first one. And this I don't need a calculator for. One last thing to point out here before we move on is look at what happened to the number in front of it. It changed to 18. I want to relate that back to the original problem because this is something you can look for. Look at the B value. Okay, if I were to try to find the period here, I would do 2 pi over 9, and it would give me 18. That's why the value was 18 here. That was not coincidence, and that will happen every time. Okay, now I know that may seem like a lot of steps, but with the calculator, it's not that bad. Really, the hardest part for most people is going to be to making sure they come up with that number correctly. All right. Before we move on to the next problem, I want to check the answer by graphing, and when I show this to you, you're probably going to get mad at me for making you go through everything in part B the long way. Okay, so let's go into y equals, and let's type in our equation, our original equation, 2 plus 3 cosine, and again I'm going to double up these parentheses. And I'm not going to type, I'm going to type in x, not 8 or any other number, the original function. Okay, one other way to check part A, besides just typing it in, we could have actually done something where, let me clear this out. Your calculator knows function notation. If you hit the vars key, the y vars key, function y1, it will actually substitute any x for you. So we're just checking part A. I also could have gone to the table. I'm going to go ahead and make sure my tables. I'm going to go ahead and make my table start at 8 though, just to kind of shortcut me there. Okay, I could have done that as well. Okay, so you've got options with that one. There's even another way to do that one. All right, now for the second one, what we really need to do is find out where this equals 1.3, and I'm going to do that by intersecting the two graphs. Okay. Before I just go ahead and press graph, I need to change the window, and you're going to have to do this manually. Now, since you don't really care about negative x values, I'm going to start that at 0. All right, now for our answers, our highest answer is 18.825, so I'm going to let that be 20. That should cover me on that. I don't really care too much about changing the scale. And if you look at your equation, let me look at the equation really quick. We're shifted up 2, and then I'm going to go up and down 3. So the lowest point in my graph should be -1. I'm going to go ahead and make it be -2 just to make sure I see it. And then the highest point should be 5. I'm going to go ahead and make that be 6. So now when I press graph, I'm going to see the sinusoid. Okay, this is kind of like how we were checking from 4.1. But I can clearly see the first 3 intersections. Okay, so second trace 5. And you definitely want to, I'm going to hit up so I can skip to the straight line. It's going to be a lot quicker. Oops. It's going to be quicker to go along the straight line than it would be the curve. Doesn't really matter though. Your calculator will find the intersection you're closest to, so I want to make sure when I find that first one. So that's how I can check my first positive value. To check the second one, second trace 5. Again, I guess I could have found the second one first. That might have been quicker. Enter, enter, enter. There we go. It is 11.175, which is what we came up with. And second trace 5. Third intersection. We know if we calculated the period right that this definitely should be 18.825, and it is. Okay, so this is another thing you can consider. If you get caught up on the whole rounding in the middle of the problem and your final answer is off here by 1,000th, what you get when you find the intersection is the most accurate answer. So if I asked for you to show your work algebraically, well, then you would do all of these steps, but make sure that these 3 answers here, if you check it in your calculator by graphing, that these are accurate to 3 decimal places. So you have some options as to how you go about this. All right, let's do a sine problem. Almost the exact same way. It's just going to change when we get that second equation for my general solution. Okay, so for the first part, again, you're just taking this number and you're plugging it in for x. I've already shown you 3 ways to do this. Actually typing it in, typing the f of x into y1, and going and looking up on the table, or doing y1 of. It doesn't matter. Okay, so go ahead and try this one on your own, keeping in mind that you've got to make sure you got your parentheses right. Okay, so I'm going to go ahead, and since I know I'm going to check this in my y equals, I'm going to go ahead and put it in my y equals. And this will just prevent me from having to do this lots of different ways. Although, doing this lots of different ways may allow you an opportunity to check your work and catch mistakes. My personal preference on part A is going to be the y1 of. So vars, y vars, enter for function, enter for y1, and then in parentheses putting 17.4. This is a perfect example of where the table, you could do it. You'd have to definitely change the setup because of the 0.4. This is not an integer. So my answer correct to 3 decimal places would be 4.092. Okay. And then, again, this is an approximation because we rounded. All right, now to find the second one, back to the algebraic way, you would first put 6.7 in for f of x equaling 5 plus 2 sine of pi over 4 x minus 10. Okay, first step would be to subtract 5. So if I subtract 5, I know that's going to give me 2.7. Oh, sorry, 1.7. Sorry about that. 1.7 equaling to 2 sine pi over 4 x minus 10. And then to get rid of this 2, I'm just going to divide by 2. And I'm not going to actually type that in or anything. You could. It'd be fine. It's also fine the way it is right here. Now to unpack this next, keep in mind that I'm talking about a ratio equaling to sine of an angle. So I'm going to let this expression, which is an angle, it's in radians, but it's still an angle, pi over 4 x minus 10 equaling to arc sine of 1.7 over 2. And when I type this into my calculator, okay, arc sine of 1.7 over 2, my calculator will give me the principal value. And that's good because I don't know how to do this one by hand. Okay, so let's go ahead and type that in. Arc sine of 1.7 divided by 2. We get 1.016 that is a rounded answer. If I have to use that number, I know I will. I'm actually going to use the unrounded version. So let's go ahead and write this. I'm going to go ahead and move up here. So pi over 4 x minus 10 is equal, I already forgot what it was, 1.016. And then I'm going to write plus 2 pi n. And before I continue, I need to write my other general solution. Pi over 4 x minus 10 equaling, I'll write a little line there. And to find this next one, let's think about where arcsine is. Okay, the restricted range of arcsine puts me in quadrant 1 if I'm positive, or if the ratio is positive, quadrant 4 if the ratio is negative. Now in this case, the ratio is positive, okay? And so 1.016, well, that is between 0 and a half of pi, so that should confirm that. All right, now the only other quadrant where sine is positive is quadrant 2. Okay, so let's think about how we would find the value in quadrant 2. Well, if my reference angle, which is actually the same as the principal value in this case, since it's in quadrant 1, 1.016, that's that little angle right there. If I subtract that from pi, I can find the other value. And this is from those formulas, but again, I don't think it's a good idea to memorize those formulas. I think you should always be looking back and thinking about all students take calculus and restricted range. Okay, so in the calculator, I'm going to go ahead and do that. Because I know I'm going to use this number here in a second, I'm going to store this in for alpha A, just to remind you of how to do this. Now every time I bring up A, it'll use this number. And then I'm going to do pi minus the answer, or I could actually go ahead and use alpha A since it's stored. And I'm going to store this in for alpha B. This is going to prevent me from having to write the answer over and over. So every time I type in A, it's going to use it's going to know I'm dealing with the principal value. Every time I type in B, it's going to be the other value, not the principal value, but the other value. Okay. So what was that? 2.156. Okay, let me switch back here and go ahead and write plus 2 pi n. All right, now I need to finish out solving for x. So in order to do this, I'm going to multiply by the reciprocal of pi over 4, which is 4 over pi. That will cancel pi over 4 out. I'll be left with x minus 10 equaling. All right, so this is where I need to multiply my principal value times 4 over pi. This is another place where the storing the value will work. So I'm going to go ahead and do alpha A times 4 divided by pi. Okay, so that's going to be 1.294 plus, when I distribute 4 over pi to 2 pi n, the pi's will cancel, and you'll be left with 8n, and this 8 should make a lot of sense because it is the period of the graph. Okay, add the 10. We can do this without the calculator. That's going to be 11.294 plus 8n. This is one of the general solutions. Okay, over here I'm going to do the same thing. Write it up here. Okay, so I'm multiplying to everything, both sides, 4 over pi. I'll cancel the pi over 4. I'll be left with x minus 10. Now this time when I'm multiplying my calculator, I need to multiply the b value. If you don't like this storing, you don't have to use it. It's just an option you have to keep accuracy. Another option would be to go ahead and round to 4 or 5 in the middle of 4 or 5 decimals in the middle of the problem, and then at the end round to 3. So 2.706 and then when I distribute here, again I get 8n. And when I add 10, I have 12.706 plus 8n. And this is my other general solution. Okay, so now let's find the first three values. So first three positive values, it looks like we might want to pick 11.294 and 12.706, but actually remember that n can be positive or negative. So you're not just adding 8, you could also subtract 8. And if I subtract 8 from my 11.294, I get a positive value that's smaller. So since I'm finding the first three positive, I really need to subtract 8 in this case. So that's going to give me 3.294. And if you miss that here, you'll catch it in the checking stage. And then if I subtract 8 to the 12.706, that will give me 4.706. And then my very next one would be to add 8 to 3.294, which would be this 11.294. And like I said, you would catch that in the next stage. Okay. Let's go ahead and check this one on the calculator. We already have it into y. We already have our equation into y equals. Let's go ahead and put the 6.7. And let's change our window. Okay, it looked like our last value was 11, so I'm going to go ahead and just change this to 12. Although how it was at 20 would be fine. And this time I had an up 5 and amplitude of 2, so I'm going to let my y min go ahead and be 0. And then my y max be 10, and that should allow me to see the bottom and the top. So when I see the graph, I want to make sure that I can see 3 intersections. So like I was saying before, if you miss the fact that where the intersections were, that there were 2 at the very beginning, you could see them here. And so second trace 5, I'm going to go ahead and move it over here, make sure that I'm finding the first one first. Enter, enter, enter. There we go, same as what I got on by paper, algebraically. And then second trace 5. So these two methods, obviously this way is easier. There is value in knowing how to do this algebraically. That won't be very clear to you now. You get to use your calculator on both parts, so there's really no reason to get this wrong, because even if you make a mistake algebraically, you should catch it when you're to this step. Enter, enter, enter. And there we go, 11.294. Okay, let's look at the next problem. Okay, number 3, because I've taken some time to explain this, I'm just going to go through the steps of how to do this again, but I am going to leave the checking for you to do on your own, because that's what you'll have to do on the assignments anyway. Okay, so when we plug 8 in here, I've given you lots of options. Okay, plugging in 8. Remember about parentheses though. I would encourage you to try this on your own, and your answer for this should be 2.798. Okay, that's to part A. Now let's look at part B. We're going to plug in a -4 in for f of x, -2 plus 5 cosine of pi over 11 x plus 13. I'm going to add the 2 and divide by the 5. Okay, so if I add 2, I get -2. If I divide by 5, that's going to be -2/5. And that equals cosine of pi over 11 x plus 13. Okay, now the expression for my angle, pi over 11, parenthesis x plus 13, is equal to arc cosine of -2/5. Okay, so now what I need to do is to type this into my calculator. Okay, and I'm going to leave these steps to you. I am going to move up here though. Pi over 11 x plus 13. And when you type this in, you will get 1.982, and you can store that, or you can actually round it out further. I've given you lots of options on that. Plus 2 pi n. Okay, now let's look at the other one. The other one would be pi over 11 x plus 13 equaling. Okay, let's think about this. The restricted range for cosine puts you in quadrant 1 if the ratio is positive, and quadrant 2 if the ratio is negative, which is the case here. Okay, so I'm going to switch colors here. 1.982, definitely between half of a pi and a full pi. So I'm in quadrant 2. The other quadrant where cosine is negative is quadrant 3. So if 1.982 positive direction lands you in quadrant 2, negative 1.982 would put you into quadrant 3. And many of you use the rule that for principal value, your other value is just negative. You just switch the sign, and that does work. But you don't have to memorize that rule. Okay. So hopefully by now you're already predicting what the next step is. The next step at this point is to multiply by the reciprocal of that b value, 11 over pi. And remember, when you do this, you distribute, you end up with the expression here, and I don't really need that parentheses, so I'm going to back up. Here we go. X plus 13. And when you distribute here, use your calculator for this, okay? And you will get 7.059059. And when you distribute over here, you will get plus 22n. Last step is to subtract 13, so my general solution is negative 6.059. Let me make that a little clearer. 9 plus 22n, and 22 is the period. Okay, over here when I multiply by 11 over pi, I end up again with x plus 13. And I get negative 6.941 plus 22n when I distribute. And when I subtract 13, my other general solution is x equals negative 19.941 plus 22n. Alright, now let's talk about what to do with these general solutions. They're both negative, so I'm going to have to add 22 to both of these. Now, which one of these, when I add 22, will give me the smallest positive value? The second one over here. So when I add 22 to negative 19.941, I actually get 2.059. And when I add 22 to this negative 6 number, I get 15.941. And then if you're confused on what to do next, like where should you add 22, what should you plug into n, just think always, the third value will come from adding the period to the first value. And so if I add 22 to the 2.059, you get 24.059. And you can check all of these on the calculator. I'm going to leave that for you to do on your own. Okay, last problem. I'm actually not going to work through this, because I think most of you by now are good. You really don't need another problem. I'm going to give you the answers to this, though. And that way, if you want some extra practice before class tomorrow, you at least can do this one. So the answer to part A is 2. The answer to part B, when you do the general solutions, the first one would be negative 0.443 plus 12n. The other general solution would be 4.443 plus 12n. And then further on that, the first three values would be 4.443 11.557, and 16.443. All right, one last thing I want to ask you is, do you think the answer to part B would be no solution? Ever. Not in this case. It obviously has a solution. I just gave it to you. But is it possible that I could put a number instead of 0.3 here that I would get no solution? And what would that look like on the graph? All right, let's say that this, instead of 0.3 here, I had put, let's just be extreme here, and I'd put 100. Well, my sine graph, this one in particular, and most of the ones we work with, never reach to where the y value is 100. So it would not intersect on the graph. And what would end up happening is, as you're working through the problem, when you go to do your calculator, the principal value, it'll give you an error.